right, thank you for joining us at our expo today. I am Elijah,
Deborah,
Lily.
and we are working with the Construction Association of PEI to create a safe, single-person drywall installation unit.
This is a typical sheet of drywall that one person would need to install. This is 4 by 8 feet and it can go up to 12 feet. This piece here would be about 80 pounds. So as you can tell, when manual installation, this piece would need to be lifted up overhead and then held there while being screwed into the ceiling. Those people are much stronger than I am, but you can tell it takes a pretty significant amount of effort to try to lift up. This can cause strain and injury.
to help with that problem, there's already an existing device out there, but we're about to make improvements to that design, and this is our prototype, which is an electronic update focusing on improving the adjustability and also improving the efficiency of the device.
Alright, with our proof of concept, the improvements we made were the addition of these two linear rails on the major arms to move forward and backward, and we also have two linear rails on these arms to move side by side. The linear rails for these arms are powered by this linear actuator, and the linear rails for these arms to move side by side are powered by the linear actuator seen here. Also, we have this linear actuator to assist for tilting, for angled ceiling installation and wall installation. Right here, we have this junction box which contains all our electrical connections and batteries that power the three actuators used on this prototype. And right here, we have this handheld switch control for usability.
So, how do you use this design? Well, as you can see here, we have a control box that's extendable from the lift, and it has three key features on it: the tilt, the movement back and forth in the left and right direction, as well as the forward and backward. The forward and backward and left to right offer about 4 inches of adjustability in either direction, and the tilt allows the lift to go from the horizontal position to the vertical position. As you can see here, the worker can actually climb up on their ladder, and they can control the system while they're installing drywall. Let me do a demonstration. During current installation with the current drywall lifts, the user would have to move the lift on the ground and roll it around to get in position, but ours offers the electronic adjustability so they can do it while they're installing drywall, and it improves the efficiency and the ease of installation.
So really any of the wooden parts you see here are just a model that real metal device. So all of our electronic components will be attached directly to it. And that device does have currently a manual hand crank that allows you to raise and lower it. So the final addition we would make would be to add a DC worm gear motor into our housing here, which would be attached in parallel with that mechanical crank and attached with a chain sprocket so that we can motorize the lift as well, and add just a fourth control to our controls panel here so that all the adjustments can be made from an improved vantage point. One thing that allows is that you can, we didn't model it here because of financial constraints, but that would allow the entire lift to be lowered down to about waist height so that you can much more easily load the 8-foot piece on and then make all those adjustments from a couple feet away.
In conclusion, our prototype was built of the already existing drywall device, which solves the problem of strain and injury experienced by workers, which addresses the labor shortage currently in the industry. This device helps in adjustability, which has been shown, and also improves the efficiency and allows installation at a shorter time.
We want to say thank you to the Construction Association of PEI, to the FSD technician, and to our professor, and to everybody that made this possible. And thank you guys for watching.
Bye!
Do you want to keep that in or no?
I like it.